According to the National Electrical Code, Section 210.8, residential kitchens require ground fault circuit interrupter, commonly known as GFCI, receptacles above the countertops. Non-residential kitchens, on the other hand, require ground fault protection for personnel. The phrase ground fault protection for personnel implies that any electrical outlet in a non-residential kitchen accessible to personnel must have ground fault protection. This protection can be implemented using either GFCI receptacles or GFCI breakers. Considering that breakrooms meet the definition of a kitchen under the updated code, they also must provide GFCI protection for personnel. Installing GFCI receptacles above countertops in a breakroom adheres to both the intent and the specific wording of the law. Importantly, GFCI protection isn't mandated for all electrical outlets in a breakroom, only for those outlets accessible to personnel. Outlets located in inaccessible areas, such as behind a refrigerator or within a utility closet, are exempt from GFCI protection requirements. It's generally recommended to provide GFCI protection for all accessible outlets in non-residential kitchens, including breakrooms, to maximize personnel safety. The reasoning behind this recommendation and the code itself lies in the potential for electrical shock hazards, especially in environments where water and electricity may be in close proximity. GFCIs are designed to detect ground faults, which occur when electricity deviates from its intended path and flows through an unintended conductor, such as a person. When a ground fault is detected, the GFCI quickly trips, interrupting the flow of electricity and preventing serious injury or death. To understand the specifics of GFCI protection, it's helpful to delve into the technical aspects. A GFCI constantly monitors the current flowing in the hot and neutral wires of a circuit. Under normal conditions, the current flowing in these two wires should be equal. However, when a ground fault occurs, a portion of the current returns through an unintended path, causing an imbalance between the hot and neutral wires. The GFCI detects this imbalance and trips the circuit, typically within a fraction of a second. The tripping threshold for a GFCI is typically around 5 milliamps. This means that the GFCI will trip when it detects a difference of 5 milliamps or more between the current flowing in the hot and neutral wires. This sensitivity is crucial because even a small amount of current can be dangerous, especially when it passes through the human body. The location of the GFCI protection, whether at the receptacle or the breaker, affects the scope of protection. A GFCI receptacle protects only the outlets downstream from the receptacle itself. A GFCI breaker, on the other hand, protects the entire circuit, including all outlets and devices connected to it. When selecting between GFCI receptacles and GFCI breakers, several factors should be considered. GFCI receptacles are generally less expensive and easier to install, making them a suitable option for protecting individual outlets. GFCI breakers, while more expensive, offer comprehensive protection for the entire circuit and are often preferred in situations where multiple outlets need to be protected or where it's difficult to access the wiring for individual receptacles. In non-residential kitchens and breakrooms, it is important to consider the specific appliances and equipment that will be used. Certain appliances, such as refrigerators, may not be compatible with GFCI protection due to the potential for nuisance tripping. A refrigerator, for example, may have a slight current leakage to ground during normal operation. While this leakage is not dangerous, it can be enough to trip a GFCI. For this reason, it is common practice to exclude refrigerators from GFCI protection. However, it is important to ensure that the refrigerator is properly grounded to minimize the risk of electrical shock. In situations where GFCI protection is not suitable for a particular appliance, alternative measures can be taken to enhance electrical safety. One option is to use an equipment grounding conductor to provide a low impedance path for fault current to return to the source. This can help to prevent the buildup of dangerous voltage on the appliance's enclosure. Another option is to use a double insulated appliance, which has 2 layers of insulation to protect against electrical shock. Double insulated appliances do not require grounding and are often used in situations where grounding is not practical. It is also important to consider the placement of electrical outlets in kitchens and breakrooms. Outlets should be located in convenient locations, but they should also be protected from physical damage and moisture. Outlets located near sinks or other water sources should be GFCI protected to minimize the risk of electrical shock. Outlets should also be located away from areas where they could be easily damaged by carts, equipment, or other objects. Regular inspection and testing of GFCI devices are essential to ensure their proper functioning. GFCI receptacles and breakers should be tested monthly to verify that they are tripping correctly. To test a GFCI receptacle, simply press the test button on the receptacle. The receptacle should trip, interrupting the flow of electricity. To reset the receptacle, press the reset button. If the receptacle does not trip when the test button is pressed, it should be replaced immediately. To test a GFCI breaker, press the test button on the breaker. The breaker should trip, interrupting the flow of electricity to the circuit. To reset the breaker, move the breaker handle to the off position and then back to the on position. If the breaker does not trip when the test button is pressed, it should be replaced immediately. In addition to regular testing, GFCI devices should also be inspected periodically for any signs of damage or wear. Damaged or worn GFCI devices should be replaced immediately. It is also important to ensure that GFCI devices are properly installed and wired. Improperly installed or wired GFCI devices may not function correctly and could pose a safety hazard. When installing GFCI devices, it is important to follow the manufacturer's instructions carefully. It is also important to ensure that the wiring is properly connected and that the device is securely mounted. If you are not comfortable installing GFCI devices yourself, it is best to hire a qualified electrician. In summary, GFCI protection is an essential safety measure for kitchens and breakrooms. By providing GFCI protection for all accessible outlets, you can significantly reduce the risk of electrical shock and ensure the safety of personnel. Remember that the NEC 210.8 dictates specific requirements, so always refer to the latest version of the code for the most up-to-date information. The proper application of GFCI protection is a critical component of electrical safety in these environments. Furthermore, consider the specific needs of your installation, including the appliances being used, the location of outlets, and the accessibility of those outlets. And regularly test and inspect your GFCI devices to confirm they are functioning correctly. The intent of the code is to protect people from electrical shock. Although this answer gives a recommendation to apply GFCI protection to all accessible outlets, this is not necessarily what the code requires. Again, you should consult with a qualified professional to ensure the work meets the applicable codes and standards in the area. Additionally, it is important to understand the different types of GFCI protection available. Firstly, there are GFCI receptacles, which are installed in place of standard electrical outlets. These receptacles provide GFCI protection only for devices plugged directly into them. Secondly, there are GFCI circuit breakers, which are installed in the electrical panel. These breakers provide GFCI protection for the entire circuit, including all outlets and devices connected to it. Thirdly, there are portable GFCI devices, which can be plugged into a standard outlet to provide GFCI protection for tools and equipment used in wet or damp locations. The choice of GFCI protection depends on the specific application and the level of protection required. For example, in a residential kitchen, GFCI receptacles are typically installed at all countertop outlets to protect against electrical shock when using small appliances near the sink. In a commercial kitchen, GFCI circuit breakers may be used to protect entire circuits that serve multiple outlets and appliances. Portable GFCI devices are often used on construction sites or in other locations where temporary electrical power is needed in wet or damp conditions. In addition to the type of GFCI protection, it is also important to consider the class of GFCI device. There are two main classes of GFCI devices, Class A and Class B. Class A GFCI devices are designed to trip when a ground fault current of 5 mA or more is detected. These devices are typically used in residential and commercial applications where the risk of electrical shock is high. Class B GFCI devices are designed to trip when a ground fault current of 20 mA or more is detected. These devices are typically used in industrial applications where the risk of electrical shock is lower. It is important to select the appropriate class of GFCI device for the specific application to ensure adequate protection against electrical shock. Another important consideration is the wiring of the GFCI device. GFCI devices must be wired correctly to function properly. The hot wire, neutral wire, and ground wire must be connected to the correct terminals on the GFCI device. If the wiring is incorrect, the GFCI device may not trip when a ground fault occurs, or it may trip unnecessarily. It is important to follow the manufacturer's instructions carefully when wiring a GFCI device. If you are not comfortable wiring a GFCI device yourself, it is best to hire a qualified electrician. In addition to proper installation and wiring, GFCI devices must also be tested regularly to ensure that they are functioning properly. GFCI devices should be tested at least once a month by pressing the test button on the device. When the test button is pressed, the GFCI device should trip, interrupting the flow of electricity. If the GFCI device does not trip when the test button is pressed, it should be replaced immediately. It is also important to inspect GFCI devices regularly for any signs of damage or wear. Damaged or worn GFCI devices should be replaced immediately. GFCI devices are an important safety device that can help to prevent electrical shock. By following these tips, you can ensure that your GFCI devices are properly installed, wired, tested, and maintained, and that they are providing adequate protection against electrical shock. Ground fault circuit interrupters are life-saving devices and are essential for protecting people from electrical hazards. There are different types of GFCIs. Firstly, receptacle-type GFCIs replace standard outlets and protect only devices plugged into them. Secondly, circuit breaker GFCIs install in the electrical panel and protect the entire circuit. Thirdly, portable GFCIs offer temporary protection for tools and equipment used in wet locations. When selecting a GFCI, consider whether you need protection at a specific outlet or for an entire circuit. If you need protection at a specific outlet, a receptacle type GFCI is a good choice. If you need protection for an entire circuit, a circuit breaker GFCI is a better choice. Portable GFCIs are ideal for temporary protection in wet locations. The National Electrical Code, NEC, establishes the standards for electrical safety in the United States. It outlines where GFCI protection is required to minimize the risk of electrical shock. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The specific requirements for GFCI protection can be found in NEC Section 210.8. This section specifies the locations where GFCI protection is required for both dwelling units and non-dwelling units. Dwelling units include residential properties such as houses and apartments. Non-dwelling units include commercial and industrial properties such as offices, stores, and factories. For dwelling units, GFCI protection is required in bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, and laundry areas. For non-dwelling units, GFCI protection is required in bathrooms, kitchens, rooftops, and outdoors. The NEC also specifies the types of outlets that require GFCI protection. For example, all 125-volt, 15 and 20 amp receptacles in bathrooms must be GFCI protected. The NEC also provides exceptions to the GFCI protection requirements. For example, GFCI protection is not required for receptacles that serve appliances that are not easily moved, such as refrigerators and freezers. GFCI protection is an important safety measure that can help to prevent electrical shock. By understanding the NEC requirements for GFCI protection, you can ensure that your electrical system is safe and compliant with the latest codes and standards. Remember that electrical work can be dangerous, so it is important to hire a qualified electrician to perform any electrical work in your home or business. A qualified electrician will have the knowledge and experience to ensure that the work is done safely and correctly. Firstly, always de-energize the circuit before working on it. Secondly, use insulated tools. Thirdly, wear safety glasses. By following these safety tips, you can minimize the risk of electrical shock and injury. In addition to GFCI protection, there are other safety measures that can be taken to prevent electrical shock. These include using ground fault circuit interrupters, arc fault circuit interrupters, and surge protectors. Ground fault circuit interrupters, GFCIs, are designed to protect people from electrical shock by detecting ground faults. Arc fault circuit interrupters, ASIs, are designed to protect against electrical fires by detecting arc faults. Surge protectors are designed to protect electronic equipment from voltage spikes. By using these safety measures, you can create a safer electrical environment in your home or business. Electrical safety is everyone's responsibility, so it is important to be aware of the potential hazards and to take steps to prevent accidents. By following the tips in this presentation, you can help to keep yourself and others safe from electrical shock and injury. GFCI protection should be tested monthly using the test button on the receptacle or breaker. If the GFCI fails to trip, it should be replaced immediately. Do not attempt to repair a GFCI yourself. Contact a qualified electrician for assistance. Keep electrical cords and appliances away from water. Do not use electrical appliances in the bathtub or shower. Do not overload electrical outlets or circuits. Use extension cords sparingly and never run them under rugs or furniture. Have your electrical system inspected regularly by a qualified electrician. Remember, electrical safety is not just about following the rules, it is about using common sense and being aware of the potential hazards. By taking these steps, you can help to create a safer electrical environment for yourself, your family, and your community. If you are working on an older home that does not have GFCI protection, it is important to upgrade the electrical system to meet current codes and standards. This may involve installing new wiring outlets and circuit breakers. Upgrading the electrical system can be a costly project, but it is an investment in the safety of your home and family. A qualified electrician can assess your electrical system and recommend the necessary upgrades. In addition to upgrading the electrical system, it is also important to make sure that all electrical appliances and equipment are in good working order. Damaged or worn electrical cords should be replaced immediately. Appliances that are not properly grounded should be repaired or replaced. Electrical outlets and switches that are cracked or broken should be replaced. By maintaining your electrical appliances and equipment in good working order, you can reduce the risk of electrical shock and fire. Remember, electrical safety is an ongoing process that requires vigilance and attention to detail. By following the tips in this presentation and by taking the necessary precautions, you can help to keep yourself and others safe from electrical hazards.